All right. Well, everyone, I just want to welcome you to today's webinar, part of our plan review series. And so today we're going to talk about and look at some of the components for the commercial mechanical section, which is the lovely C403. And C403, I would say, is probably one of those sections of the code that may not have been everybody's favorite section of the code because um, mechanical is not something that everybody goes out and reviews. But as we've mentioned in the past, the energy code is not trade specific, right? The energy code wants all of the trades to come into the sandbox and play together. And so sometimes it's the mechanical person that's doing the review, and sometimes it might be the I do all of it plans examiner. And so commercial mechanical energy can feel like a really daunting task. And hopefully, we're going to be able to show you little bits that you start to get comfortable with. And then once you're comfortable with something, you can always move on to, okay, I'm going to tackle this section now, right? So nobody can eat an elephant in one bite. Um, it uh, it's just something that you have to take bits and pieces to get a full understanding on that. I did put the handout in the chat. Hopefully it is able to work. I'm having some difficulty on my end, so um, I'll try it again, and then we'll just keep on trucking along. So the section that you all know that I appreciate and enjoy the most is C103.2. And the reason why I love this section, especially as a plans examiner, right, is because this is the section that says I need XYZ placed on the construction documents so that I am able to actually be able to perform a review when it comes to mechanical energy or really anything with energy, right? And this isn't a new concept because all of the codes have a section in them that reference, things that need to be placed on construction documents. So it is something that's out there. It's available, and it's also a great guideline. If by chance it's not in a code, you can pull it up and say, okay, so these are the things that I may need. But as far as the energy code goes, 103.2 is there as a tool, and these are all the criteria of what we need in here. So you'll notice that we have 6 items out of the 13 that can pertain to what we need as far as items on our plans that pertain to the mechanical code. So we're going to kind of walk through these here and we'll move forward. So the first one that we're going to take a look at is what do we have for those mechanical systems and that design criteria, because that design criteria is incredibly important to determine, do we have the correct size of mechanical equipment? Are we designing it? We aren't going to try to design a heating system for, -3 in, I don't know, if in Roswell, right? It probably doesn't get to be a -3 in the wintertime. And if it is, we probably have a little bit more problems to worry about than this, right? It's a weird year if that's going on. So when we talk about mechanical system design criteria, we're looking at for things like your winter dry bulb, your summer dry bulb, what are our conditioning days, right? How many, what are the months? What is the time of year that this building, the structure is actually going to be conditioned? What's our wet bulb? And then our indoor Our indoor temperatures, right? What are we designing our indoor uh, comfortability to actually be in all of this? Excuse me. So where we might find this as far as for a plans examiner, right? Anybody have any thoughts, or where has anybody else found this information? I'm not going to tell you if you're right or wrong. All right. Well, one of the places that you can find this information as it's required out of 103.2, quite possibly, Carl, quite possibly, is one of the places you can find it is either on your heating and cooling load calculations, which is this report right here. You know, we have our dry bulbs, our wet bulbs being involved. We've got, you know, the condition days on there. Another one is here's some information about how the HVAC design is. What are some of the things that went into that design? So here it gives us what our dry bulb temperature is, our wet bulb temperature, our relative humidity. So we have some of that information, and it can be in various locations as such, right? So this is one of those things that really makes it incredibly beneficial. Oops, I moved through to have that heating and cooling load calculations, because that information has to be provided there. And a lot of times you'll also see that information provided on the plans in this schedule possibility. Sometimes I do see it in the mechanical general notes. They'll say here is our design criteria that they utilized for it, the system. So there's a few places that you could get that information. Now, as a plans examiner, something that we would want to ensure is, you know, obviously, is the temperatures correct, right? Um, are we looking at this is a seasonal building and so forth? So, you know, there are some things that we would want to verify, but knowing where to find this information is incredibly important to be able to translate it down the road. Now, the next thing to really discuss in that list of items out of 103.2 is our systems, right? We have our mechanical and service water heating systems. And with those systems, we have to know what type of appliance is it, how big, what are the sizes of it, right? And how efficient is that particular equipment, right? So that's something that's incredibly important to do, because we know that when everything is said and done, that it is truly the mechanical systems that has that tangibility, right, of energy efficiency, because our utility bills, we're able to visually see it, and probably our pocketbook visually see it too, right? And then you're required to give an economizer description. Sometimes you get that information on your mechanical equipment schedule. There's also another place you can get this information. Your fan motor, I always say this wrong, fan motor horsepower and the controls, right? So a tool that's out there, and as a plans examiner, it's an incredibly useful tool for you to help get some of this information, is your ComCheck, your mechanical compliance certificate, right? Because in that software that they're putting that information in, they're letting you know what type of heating systems and cooling systems they have. They're telling you what size those systems are and what the efficiencies are. It also has criteria in there for the service water heating. So you get the what type of water heating system are you going to have? What size is it? What are the efficiencies? Because there's criteria and requirements in the code that pertain to all of that, right? And when we go into 403, it gives us that. Then economizers, right? If you go prescriptive at the prescriptive point, you also have to include an economizer. Well, the great thing is the economizer is also displayed in the mechanical ComCheck. Even if you utilize one of the exceptions, ComCheck has which exception you're doing. Now, it won't say because it can't tell with the systems exactly if you qualify for that, but it gives the plans examiner a great tool for that here. I do see your question in there about the handout. At the end of the class, I'll try to upload it again. It might be some issues with it uploading right now. So I'll get that out there in just a moment. And then the other one is fan motor horsepower. This is a section of the code that I will say the majority of the people out there, unless you are really, really into mechanical, it feels very complex, and we're not really sure how to interpret what those pages are, criteria on those pages are telling us to do. And the mechanical ComCheck really gives us that information to be able to determine. And the nice thing is, it also tells us, hey, this fan system as it's designed here passes or it doesn't pass, because it will also say on there, the fan system does not pass. So it's a wonderful tool to really be able to dive into all of that. Now, often when it talks about one of the things that they have, not only does ComCheck list the economizer, so it'll say it's a water side economizer or it's an air economizer. It doesn't give us the specifics of it, such as, any type of controls that are going to be going on, because there are control requirements when you go into 403 for that. And so a lot of times that specific information is often listed in the notes for the in the equipment schedule. So here we have some RTUs. It says it's going to have an economizer. That's our note number 2. So if we look at the RTUs, you'll notice we got a note 2, we got a note 2. It says temperature control, 100% outside air, relief return capability, set minimum position at CFM listed. Whoops. So that's not exactly everything we need. Sometimes you'll get it also as a sequence of operations. So it might not have all the information here, it might say, note 2 that it has an economizer. And then sometimes I'll see either it'll say C sequence of operations, or it'll just have the sequence of operations to meet all the other criteria that you find out of C403.5. All right, duct sealing, duct sizing, duct and pipe insulation, their location, terminal air, or water design flow rate. So these again are all the criteria that has to be placed on the plans for us, so that it helps us as plans examiners to actually find the information that we need. So as we just went through the first little while here of all the things that are required to be placed on the plans, now we can start looking at what some of that criteria is. So you can see, like I said, there's 13 items in there, and 5 of the 13 items pertain to mechanical. That's a lot. So the code is trying to give you every tool in the toolbox to be able to help with our plan review on this. So one of the criteria, right, was talking about our efficiency. So ComCheck does have, the report does provide, hey, here's the efficiency on it, whether it passes or doesn't pass. But how ComCheck knows whether or not it passes or doesn't pass is because if we go into C403.3, and this is the section that says all of this equipment, all of our heating and cooling equipment has to meet these minimum efficiencies, and it has to be out of one of these 16 tables. So here is a list of the 16 tables that look fairly comparable to what we see on the screen here. I didn't put all 16 tables in here, but I did show you that they have tables broken out into the plethora of different types of systems or equipment that can be used to do that heating and cooling. And so you'll notice, but it is an awful lot. And so how do I know, looking at this table, this table as we see on the screen and the 16 types, how do I follow through and look at all of this and try to figure out, did they use 6 when they should have used 7? I don't know. I'm not that deep into mechanical that, it makes a lot of sense for me that I can understand exactly which table do I go to. And I'm here to say that it's okay if you feel that way and you're like, I'm not sure what I need to review to, because the reality is you have tools out there that can help you with this. Like I said, there is the mechanical compliance certificate here that really does illustrate what we're looking for here. So in this particular one, we've got, our HVAC here. And it says our heating is going to be a central furnace. It's gas. It's 50,000 BTUs. It says they're proposing, that's what they want to install, is going to be an 80% efficient appliance. And they said by code, it's only required to be an 80%. So because it's meeting it, it's letting us know that, hey, their design works for this. With what they have and what they put in there, it does work. Now, and I'll also let you know, if it doesn't work, there will be a notice on there that says doesn't meet the efficiency. The heating equipment doesn't meet the efficiency. And it's a red note that comes up on all of that. Also, for our cooling, right? Our cooling is letting us know we're proposing that it's going to be a 15 SEER 2, because remember, we're into the 2s now. And that what's required is the 13.4 SEERs 2. So the minimum that they had to do was 13.4, and they're going beyond that and installing a 15, which is perfectly okay, right? They're more than able to do it. Now, it's not uncommon to see things such as SEER, but it also has EAR, right? EER, and that's our energy efficiency ratio. So one is done at the 90-degree mark. What's the efficiency of the 90-degree mark? And then the other one is what's the efficiency all throughout that season. So now what I do is I take this information, right? And then I verify with what I see on the plans whether or not it meets that efficiency criteria, because there'll be a mechanical schedule. And in that mechanical schedule, it'll have efficiencies in here. So I would take for this PTAC, it says 13. And I would come over here and it says, oh, on here it says that they're proposing that it's going to be an 11, but we'll pretend like it's the same here, right? And I would verify that, okay, what's listed on the plans and what's in the ComCheck, they match, and we can call it good because it's a trusted source and it helps us because, again, not all of us are mechanical engineers that dive into this, but we have that responsibility to review this type of information. All right, and then the same thing when it comes to our RTUs, right? Our RTUs, we would have to go through and verify, because here's our input, here's our output. Remember, when we're sizing our equipment, we always look at the output, but we also want to know what the efficiency is of the appliance. These all call out that they're 80%. And if we came back here, it says that they were going to do 80%. So we could call it good. And then you would go through and do the same thing and look at what our cooling capacity is, because we went right here where the heating capacity is. Let's see if I can get that up there so we can. There we go. So that we can see it here. So here's our cooling, and this is the information for the cooling. And right here gives us our SEER and EAR rating. And And that lets us know that, are we actually making to what we need to be making, right? So it matches what our com check has. So that's all we do. That's a very easy step to try to navigate in all of this. Now, to ensure that the equipment that is shown in that com check is actually correct, we have to do heating and cooling load calculations. And so when we talk about our heating and cooling load calculations, what we need to do is we do need to realize that there are some things that come into play with that, right? So it takes into account elevation, our heating and cooling degree days, the amount of glazing, the direction of the glazing, the type of glazing, the solar heat gain coefficient, the overhangs, right? The solar heat gain coefficient is so important, especially in our climate zones 3. It's important too in climate zone 4, Clovis, but when we start getting into those really cooling dominated environments, the amount of solar radiation heat that comes through the windows and isn't reflected out makes a big impact on how hard that cooling system has to work. And so the solar heat gain coefficient of those windows are incredibly important, along with the overhangs with it. So then again, your insulation values, because that's all part of it, your roofing material and the design of the roofing, are we talking about light, dark, lighting? Lighting used to have a huge impact on our heating and cooling loads. The nice thing is, they're getting a lot better, right? Because the lighting and electrical manufacturing industry, like I've said before, really took hold of the energy code and has been producing some really good items in there. And so while it's still a part of it and it still has a big impact on things, the number of lightings, the type of lightings really, comes into play. And then your occupant load, right? Because we all produce items. And so again, we're going to take, components that are within our heating and cooling load calculations. And through all of this, if it said, hey, you need a 60,000 BTU, whatever heating equipment, that's where we can then go to our mechanical compliance certificate from ComCheck and verify, right? So if it says you need 50,000 BTUs, we look at for our heating, and right here is the capacity of the mechanical equipment that we're installing here. And me as a plant examiner, I can look at this. It says the heating and cooling load calculations say it can't exceed 50,000. I then can look on here and it says 50,000. And I'm like, okay, that at least these parts are matching. And once these parts are matching, then I can go with the next step. And we'll talk about that next step in just a moment. But we're going to take that same process for our cooling, right? So here's our cooling, and then here's our capacity. It's 30,000 kBTUs an hour. So now if I go back and I look at what the cooling loads are through our heating and cooling load calculations, and if it says that 30,000 is what we need, and I look at this and it says 30,000, at least I know those two things match up, right? And then the next part of the equation is taking that ComCheck where it says it's going to have a capacity of, in here, it says 100,000 BTUs. Remember, we always want to look at what the output is, right? And so here we go. We could then take and verify what we have here and ensure that it's going to match the capacity that we have here. So if we added all this up, then, if it hit that 100,000 kBTUs, we know that we would be okay, right? Now, I will say that just so that everybody's aware, the com checks are not matching any of these examples. So, but that's the process in doing it. So as you can see, we've got tools that is going to help us and verify and move us into having more comfortability in reviewing these commercial mechanical systems, at least as far as how it goes to for the energy side of it. All right. So here's another thing we have to think about. Whenever we talk about the energy code is big on controls, right? So we are required to have thermostatic controls for all of our systems or our zones, right? Because sometimes they're zoned, it's not a single zone in there. But for all of our zones, we have to have controls. That control has to have the capability of being programmable, that the temperatures are set, it's got an override, it could control the humidity. Of course, we don't really use the H word so much because we don't always have humidity. But if we were in, a different location, the Midwest where humidity is crazy, that would be important. But that isn't necessarily important for us. But what we would need to do is verify on the plans that we have that lovely symbol that is typically shown on these plans, which is a T with a circle around it. Now, they could utilize a different symbol for it. And all I do is I look at the legend of the plans and see. So if I start looking at the systems and I'm not noticing the typical T with the circle around it, I'll look at the legend and see what did they choose to utilize as their thermostat for it. But in this particular instance, you'll see for every PTAC, it has its own thermostat for it, which is what is required by this previous section we just talked about. So this plan demonstrates that it meets the criteria. Now, the second half of that, because remember, it has to be able to be have the ability for various types of controls, right? Programmable to be able to shut down or go to the setback. So it has to have that capability. And where you're going to find stuff like that is going to be like in a sequence of operation, which we'll talk about here in just a moment. But let's talk about deadband, right? Because I think this is another one of those sections that often feels like they're talking in circles, right? When do I have to do this? When do I have to do that? And hopefully we can make this a little bit easier. So 403.4.1.2 is the section that you would go to for your deadband when you have one thermostatic control that's going to control both the heating and cooling systems. So you have one thermostat for both systems. Now, for the deadband criteria, you have to have where it has separate set points for your heating and cooling, but it also allows that the person can adjust that, right? It also has to ensure that those set points are at least 5 degrees from each other. So the idea is that when you are trying to cool it or heat it, that you aren't triggering, then it has to get cooled because the cool says, ooh, we have a set band of 1. Well, you decide to set it at 2. Now, all of a sudden, you have both systems fighting each other. And that's kind of what the 5-degree separation is really trying to do there. And then it also has to have the capability that when things are adjusted, it only is adjusted by 1 degree. So it doesn't skip 5 degrees, it's that 1 degree. So when you say, hey, I want to change it from 60, it can go to 61. So now this section, C403.4.1.3, remember this is 2, this is 3. And this section is saying, okay, when you have 2 thermostats in a single zone, and one is going for the heating and one is going for the cooling, now what we have to do is have some controls involved, sequence of operation, all of that fun stuff that does not allow the thermostat for the heating to kick on when the thermostat for the cooling is trying to operate the way that it should be operating. And how this is done is you could have it with a limited switch. You can also utilize a direct digital control system that has software programming that's going to take care of that. So you would see something like this again, like on a sequence of operations. All right. Now, this one is talking about for, off hour controls, right? We want to make sure that nobody's there, that do we have to have it like this? And so this is really talking about that for this, you're going to either have it where it's on a software program system that says, okay, these controls are going to be set this way, or you can have it on an automatic time clock. Think about it as like at a hotel, right? I think we've all been to a hotel where you come back to the room and you're like, I had it set at 65 and now it's at 70 or what have you. So, things like that would be on an automatic, or it might be, or that one is probably on a timed situation. Now let's talk about some of the fun things that go along with this, right? Our off-hour controls. This is saying, hey, we have to have this. And then this is some of the criteria with it, right? You have one control, and it's not required for both. And then when you have a control for cooling, then it's going to have to maintain that temperature is at least 85 degrees or higher. And when you have a control that is for heating, it has to maintain temperature that's at 55 degrees or lower. And we also have to make sure that we have that automatic setback and shutdown, right? So basically, that thermostat is going to be have the start stop, and it's going to be for different schedules for different days, right? It has to have the ability for 7 days and different schedules within that 7 days. Now, it also has to have the ability that if the power goes out, it maintains that programming that we just set up for those 7 daily schedules, right? It has to have the ability that it can maintain that programming for up at least 10 hours. Now, it also has to have the ability that there can be an override manually that happens for that. And that override has the limitations for up to 2 hours. And there is always the possibility that you might have to have an occupancy sensor with that. Now, the automatic start stop option in here is that, our set up with that schedule, right? That you're going to start and stop that system as it had been scheduled and alluded to with all of that. Now, there are some controls in here that are required that's going to, when you're dealing with the heating, that's going to decrease the temperature by 2 degrees and increase it by 2 degrees when it's cooling. So basically what it's doing is when everybody's here and working, if the temperature is supposed to be 60 degrees for our cooling, that's a really cool one. But when everybody's gone, then it says, okay, now we're going to bump it up to the 62 degrees to adjust and handle for that. Now, like I said, this on a set of plans typically is called out with a sequence of operations. So this was a list of all these control systems and how it was going to be, reduced or, produced and done with that. So here we have right here, it says unit shall be started and stopped from a 7-day programmable thermostat. All operational and safety interlocks shall be wired, including the unit shutdown from apartment smoke detectors. It also says you have to have a local space temperature, use of the electric refrigeration and heating, domestic hot water. So you'll see that a lot of times what I'll get for that, it may not be as specific as that, but this says, here are the controls, right? Here's all the controls that are involved with it. So now we know we have that 7-day programmable thermostat. And then often out of the notes, You then turn to where the sequence of operations are, and it'll say, so for our start stop 7-day programmable, it's going to be programmed that from 9 to 3, it's going to be this, and have various things. Of course, I'm trying to think of a sequence of operation off the top of my head, and it's not coming to me, but that's typically how we would find that information on a set of plans. Now let's talk about vestibules. Vestibules, if they are heated or cooled, and this came into the code, I think it was in 2015. No, it was 2018 maybe. And the reason why it was put in is because vestibules were required to be heated or cooled, or not heated or cooled, but it was required that vestibules had to be installed, right, in all of our main building entrances. Well, the problem that was happening was in these colder locations, we have this thing called, we have sprinkler heads and, sprinkler piping and stuff that is in those vestibules because it's required by code. Well, what was happening was in those colder climates, when the doors were opening and everything, it would be probably warmer than the -3 degrees outside, but it was still not warm enough to keep the pipes from bursting. And so it was put into the code. Okay, the original code proposal was just to heat it enough so that those pipes didn't burst. Well, then it became, people took it as, an opportunity to kind of have that buffer. So now what it is you do have to have, if you're going to heat or cool your vestibule, you have to have an independent control located in the vestibule for the vestibule. And then you're only permitted to heat it up to 60 degrees, and you're only able to cool it down to 85 degrees. So here's an example on a set of plan of where we have it. So here's our vestibule. It's calling out that we have this cabinet heater that's going to be done here. So it shows it here. And then on another part of the plan, it shows it here with all of our wiring and everything, and our thermostat, because you have to have a thermostat and it has to have its own control located in the vestibule. So they met that criteria. Now, if we look down here too, right, it says it's CUH1. We have all of this fun stuff. It has notes 1, 2, 3, and 4. It has information. 3 says provide with unit mounted thermostat. It also has additional criteria, right? It says it has a thermostat, but is that thermostat running in the function that we need for here, right? 60 degrees, 85 degrees. And so you go to the sequence of our operation, and here it says provide a wall-mounted thermostat to automatically open the normally open 2-way control valve and cycle the fan motor to maintain the thermostat set point. When the outdoor air temperature reaches that 45 degrees or above, then the heating and cooling shall be locked out, which is an additional item. The 45 degrees outside is not a criteria of this section. The only thing that they were missing on here is they had to call out that it could not heat more than 60 degrees and it could not cool more than 80 to 85 degrees. So really close. We walked through the progression of it. It just needed to have that additional note on there. Now we can't leave boilers out, right? So there is a control there for boilers. And basically what it says is the boiler needs to be on, right? We're trying to do it, but it's also based off of what is the temperatures outside. We don't want the air conditioner, to cool the room down to 65 degrees. And then the boiler says, ooh, we're at 65 degrees. We got to kick on and make sure it's warm. We don't want our occupants to freeze, right? So there's a control that does that because there's an additional sensor, basically, that's located outside, and it says, whoa, it's 110 outside. We don't need the heat on. Let the air conditioner do its thing. You just take a break. This is your vacation, right? So it's all of these things working together. And typically how you'll see it is on the set of plans when you have the equipment schedule, it'll say I have an outdoor temperature sensor that, and it has it'll have a little note. Sometimes you'll see it where it might call it out in the actual mechanical notes. I haven't really seen where it's put into a sequence of operations, but that's a very strong possibility. I'm usually seeing it as a note. Now that I say that, all of a sudden everything's going to come in as a sequence of operations. All right, economizers. So it is required if you are utilizing the prescriptive path that you're going to install economizers. Now you can use a water side, you can use a air economizer, but these are installed for cooling systems, which you go down to Hobbs, you go down to Roswell, it gets a little warm. We like those cooling systems. And so an economizer is basically a giant damper, right? And so when the air outside is cooler than what what the demand is, that opens up the damper and it allows that cooler air to come into the system that kind of preconditions it. So then it is not really warm air that it's having to cool. It's a little bit tempered down air. And so you aren't utilizing as much energy for it. But once the air outside gets to a point where it is no longer a benefit, then the damper shuts and we call it good. So this is required for all those systems unless you happen to have where you fall under the exceptions. And these are the exceptions. The first one, unfortunately, doesn't really qualify for us, but we might have a system that runs less than 20 hours a week, right? So there is a possibility that that might be an option in all of that. But again, as I mentioned earlier, your ComCheck could be a great tool for it because right here it tells us whether it's a water side or an air economizer. And then it also it also shows us where if an exception is utilized, which exception did they use? A low capacity residential, which remember is one of the ones here that you can have. So this is something to just be aware of. It's there. It's a wonderful tool to have. Now I want to talk about the available fan horsepower. This is again one that really is difficult sometimes to try to navigate and wrap your head around. It took me a long time to try to figure out when this applied, how this applied. How do I read the, engineeringese that this section was speaking, right? I had to learn the language. And this is a requirement that happens when you have the fans that are part of that HVAC design. And the nice thing is you do have two options in how you can do it. There's the nameplate motor horsepower option, and that one is probably the easiest one or the simplest one out there that gets utilized a lot, right? It's one that it's not a no-brainer by any way, shape, or form, but it does utilize less brain cells to figure out. And correct me if I'm wrong, if I have any mechanical engineers that say, no, that one's more difficult, but from the plan review side, I think it's a little bit easier. And then your second option is utilizing the brake horsepower for it. Now, this one has a little bit more complexity to it because it's not just straightforward, hey, look at the table and call it good. There's a little bit more involved with it. Now, this section only applies if you happen to have a single fan and that single fan exceeds 5 horsepower, or you have multiple fans in a system and when you add them up, accumulate them, it accumulates to 5 horsepower or more than 5 horsepower. Now, here are the exceptions for it as to when it's involved. So here's, like I said, here's the nameplate horsepower option. And this one, the idea of all of this is really that we are trying to size the fan appropriately so that we aren't oversizing the fan for what the system needs are or the design of the system, right? Now, it does also talk about that kind of as an exemption, fans that are part of the variable frequency drives, those are not part of the calculation. And if you have fans that have a nameplate horsepower that's less than 1 horsepower, then you're exempt unless it is utilizing electrical input power, and then it's a 0.89 kilowatts, right? Because we have to be understanding that you could be utilizing electrical. Now, we have to ensure that we have fan efficiencies, right? We're trying to, obviously there's a lot of efficiencies involved here. So we have fan energy index criteria. And that fan energy index criteria has to be at least a 1. Now, here's a definition of what it is. But while I say that your fan energy index has to be at least a 1, if you have a variable air volume system, now your fan energy efficiency index number has to be at least a 0.95. Now, there's a plethora of exceptions for our fan efficiency, but I want to get us to the point of what are the available tools that we have out here. So again, I come to the mechanical comm check because this mechanical comm check lets me know where we are at on things. So here is my allowable fan horsepower. They used option 1. They're telling me that it's a 5 horsepower, and then it has an efficiency, a fan efficiency of 5. So remember, it had to be at least 1. So this kind of knocked out a lot of the things on there. The other really great thing is you'll notice right here, it says fan system compliance. They're using the motor nameplate horsepower method, which was our option 1. And it says with the information that was inputted, it passes, right? And that's the really important thing for all of us to know. And as you can see here on the screen, it gives us that information. Now, sometimes it'll have in the comm check, it'll say unspecified for the fan system. In this instance, it really should show, which option they utilize, what the CFM of the fan, what's the efficiency of the fan, and, if it passes or not. But sometimes when you go into comm check, if you don't link the fan system to the mechanical equipment, this is how it's going to show up. So this could be where it didn't have that link. So you can say, hey, let me know. I don't see any information here about your fan system. Does this system not qualify to provide, this option because it's less than 5 horsepower, right? And so that is a good thing to know. Or did you not, link the two together? Which often it's just that they forgot to click the button to make them linked. It happens. It happens a lot. I can say that because I've been in there many a times where I forgot to link it. All right. We'll kind of end a little bit here we're getting towards the end here with our energy recovery. So energy recovery is a criteria. It's not always required, and we'll get to that in a minute. But what I want to talk about is what are the types of energy recovery that are out there. We have the energy recovery wheel. So we have the wheel, we have the corrugated. I always think of corrugation on there. Can't think of the word I want to use right now, but we have that within that wheel system itself. And I'll tell you that 9 times out of 10, it is the energy recovery wheel that I see on the plants. Now, another type is the flat plate option. And this is very, very similar to what we see residentially in my brain. This is how I think about it, is that it's very similar to what we have when it comes to the residential side, right? So if we have an ERV or an HRV, right, that is how pretty simple concept of that one. Now there is also this third option. This is the run around loop, and the run around loop is not necessarily one that is uh, really utilized a lot. But what it does do is it transfers that sensible heat between the exhaust and the fresh air, and and all that fun stuff that happens with it. But this is not this isn't one that I actually have ever seen on a set of plans. So just, keeping that in mind there. All right. So here's our requirement for our non transient dwelling units. So in non-transient dwelling units, you're going to have that energy recovery ventilation system here. The important thing is you have to pay attention to what the entropy recovery ratio is. So it has to be 50% for your cooling system and 60% for your heating design system. Now, there are some exceptions for that. The location that has the exception here is Clovis. You are in climate zone 4. So in climate zone 4, it says that you're going to have to make sure that the heating system has an entropy recovery rate that's, at least that 60%, but you don't have to worry about the cooling system. But for everyone, Roswell, Hobbs, Carlsbad, you have the opportunity that you get to pay attention to both the heating and cooling, unless it happens to be for dwelling units that are less than 500 square feet in that sense. If you're 500 square feet or less at that point, then they're not worried about it because that's our climate zone 3 right here. All right, so how does Hope see this on a set of plans? Well, there we go. I'm going to see if I can't get my little highlighter. There we go. So here is the full section that's dealing with the energy recovery. Here is this part here. And then this is just specific to this section here that's dealing with the energy recovery in here. And you'll notice that it's calling out that they're going to use an energy recovery wheel, which, as I mentioned, I see that probably 9 times out of 10. And then it's giving us some information down here. Now, what it's not necessarily telling us is what is our entropy recovery rate on it. So, but it also calls out, a lot of times I'll see it, it'll show this information here. It might not show the entropy ratio up here, but it'll be a note. So it'll say note 2, and then you go to note 2. Note 2 will say, oh, the entropy rate for the heating will be 60%, right? So it's something of that nature. That's typically how I will see it on a set of plans. Now, if you happen to be a space that isn't a non-transient unit, now all of a sudden what you're going to have to do is you're either going to have to comply with the tables of C403741 or 2, and then it's also going to have to include those recovery. And again, that entropy recovery ratio has to be at least 50%, in that design. So this is the first table. This is what you would look at. So for climate zone 3 and climate zone 4, you'll notice that there is no requirement for you, because we are 4B and 3B, that this would not necessarily pertain to you. But this happens to be when your system, your ventilation system, is going to operate less than the 8,000 hours per year. Now, if it's more than 8,000, more than 8,000 on there. Now, what we're looking at, if your 3B happens to be this row, and if you're 4B, you're going to look at this row. Now, there are some exceptions for it. As you can see, here's the first 4. Here's the next 7 that gets us to a total of 11. And I know we're kind of running out of time here. And so this is an area of where I would find that. Here's an example, right? This was a sequence of operation for our energy recovery. It had the information in here. It had this was how they had it programmed for. And then this was the information that I was looking for because it told me the things like the entropy wheel or the entropy recovery on that. Now, this is an easy one. We have to, have dampers on all of our operable openings in here because it makes sense. We've paid really close attention to our thermal envelope, and then we have big openings for our intake and our exhaust. And obviously, we want to have that. We want to make sure that we have those dampers, and so as you can see here, here is some exhaust. It has note 1. That exhaust note 1 says provide with the backdraft damper. Wow, you would think I hadn't spoken or know how to speak lately. All right, low capacity fans. So this one is in the code, but I would say that manufacturers right now are not producing things that don't meet the criteria, or at least I'm not really seeing that out in the field a lot. So this is a table. It probably looks very similar because there is one out of the residential section of the energy code, and it really doesn't differ and all of that. It is there, and it's something, right? We just want to make sure that the efficiency of the fans that's in that ERV meets this, or in the bathroom fans. We also have to ensure that we have duct and plenum insulation and that it's going to be sealed, right? So depending on where it's located, lets us know how much insulation. So if it's outside of the building, it's got to be an R8. If it's located outside of the thermal envelope, then it only has to be an R6. Typically, here's an example, right? We have a schedule that tells us here's R6. These are the minimum values. Our exhaust air recovery, they're going to have an R12. And so here's some really good information that I find on plants. Now we got our piping insulation. It is a criteria. We're going to comply with the table. Here is our table that we would take a look at. So, and so when everything is said and done, how this table works is this is the size of the piping that is part of a system. We're going to look at whatever temperature it's calling for, and then here is letting us know how many inches of insulation is actually required. Now, we do have to remember too, we have to ensure that the conductivity of the insulation is correct. And you'll see that here it is providing that information. It's telling us, the temperature, whatever size piping, because they had some piping sizes, and then how much insulation they were requiring to be put on there. It would match what's on here. And then there's the notes, and that gives us the information here about the conductivity of that actual insulation. All right. Remember, we are here to help answer questions that you have. So here is the helpline for you all in New Mexico. Don't forget, we have the website here that gives us the information and is storing our technical documents. You can come in here and hit all the technical documents out there. And again, survey will pop up. And this is me. You guys have a wonderful day. Thank you for hanging out with me this week. I hope you enjoy your Thursday. Bye, everyone. Oh, I was going to try to put that up there into the deal here. So let me see if it pops up. You guys are always welcome. The handout just went up into the chat again, so I'll stay here for just a moment so you guys can download it. Of course, everyone. I appreciate you guys hanging out with me this Thursday, and I don't know if you're going to get me or Troy next week. I can't remember. You'll get one of us. All right, everyone. I hope you have a fantastic day. Whoops.